Hello, everybody. Today we are doing lesson 7-4, and this is multiple representations. Um, so we are on page 423 in your workbook. So when we are representing the relationships between variables, we've talked about a couple different ways. We've used a table, we've used an equation, and we've used a graph. So these are all the different ways that we use. Now, it's important to understand what is the connection between all of them. So relationships between two variables can be described using those multiple representations. We use words, we use equations, tables, and graphs. By generating multiple representations of the same relationship, you can identify correspondences between the representations. Each representation describes the same relationship, yet in a different way. So let's start with words. So if we have this scenario, on a trip, a cyclist traveled at a constant speed of 14 miles per hour for several hours. We can then write that as an equation. Because we know that it's 14 miles per hour, we can multiply 14 by the number of hours or the amount of time that she cycles to then find the total distance. So our equation is d equals 14t. We can then use that equation to make a table. 1 hour, 14 miles, 2 hours, 28, 3, and 42. And finally, we can use these as if they were ordered pairs, right? 1, 14, 2, 28, and 3, 42, to then plot on a graph. So those are 4 different ways we can represent scenarios and relationships between variables. So let's turn to page 424 and let's try example 1 together. The Student Council has already earned $150 this year. For the next fundraiser, they are holding a car wash and charging $7 for each car they wash. So we're going to represent this using a couple of different ways, the equation, the table, and the graph. We're already given the words for it. So first we need to determine what is the independent variable and what is the dependent variable. The number of cars washed, C, is our independent variable. And the total earnings would be the dependent variable. We can't determine the total earnings until we know how many cars were washed. So that's why we do independent as the number of cars and dependent as the total earnings. Before the car wash, the Student Council had already earned $150. So we know that we will then just add 150 to whatever we can calculate. Now, we also know that they're charging $7 per car. So that means when we write our equation, we need to do 7 times the number of cars plus that one original 150 to then get the total earnings. Now, we're going to go ahead and create a graph to show this. So if we have $7 per car, we wash 1 car, we would then earn $7, right? But we have to add that to our 150 so that we would get 157. For 2 cars, we then add another 7 on there, okay? Or do 7 times 2, which is 14. So we'd have 164. Then we would have 171, because remember, we're continuing to increase by 7, and 185. So there would be all of our values for our tables. Remember, all we're doing is we're plugging in the values that we see in the table for C and then solving our equation to get the total earnings. Now that we have it as a table, we can use these as ordered pairs. If I were to plot this on my graph, right, 1 and 157, so I'm going to put a point here. 2 and 164. So that would go right here. 3 and 171, be right here. 4 and 178. You go right here. And 5 and 185. So we can then see the trend of our car wash. We can then draw our line. We started at 150. There we go. So that would be our graph. Now, let's take a look at our check here. So we're going to do the same kind of thing. It says an online store sells trail mix for $2.75 per pound and charges a shipping fee of $4. So whatever we're going to do, we're going to add that $4 on because we need to then figure out what it would be with the shipping included. $2.75 per pound. So we're figuring out the total cost C. That's my dependent variable C. Then we would use 275 times P, right? Which is the pounds plus our $4. Okay. So then we would go ahead and drop in our values into our table here. Remember, you guys can use calculators. I always say that. Oops, my calculator disappeared. Just slide some things around there. There we go. So start by doing 275 times 1 plus $4, right? So we would get $6.75. Now we're going to do it with 2. 275 times 2 plus $4. That would be $9.50. 275 times 3 plus $4. Okay, so as you can see, we're increasing by 275 each time. 13, 14, $15 here, and then we'd have $17.75 as our final value. Okay, then we would graph it. Simply plot your points on your graph. For 1 pound of trail mix, the cost is $6.75. So right about there. 2 is $9.50. Right about there. $12.25 there. 15 there, and 17.75 about there. So there we go. That is how we would plot our values on our table, and our graph, sorry. So that is it for today's lesson. Pretty simple. You're given one equation and you need to just figure out all the values that would then fill in. As always, please make sure to complete your homework on McGraw-Hill and have a great day.